All right, welcome back to the morning show. Coming up on 6:50, it's Wednesday. School is back in session. Literally, Matt Selden is here, our resident genius, physics guy extraordinaire, whatever you want to call him. You got plenty of names. Now, you have an answer for me.
Plenty of names, right?
Yeah, well, plenty of good ones. Guys who don't like to ask for directions, you've got it cured. You got the answer,
right? That's right. The GPS you can buy nowadays. It's wonderful, and I thought, you know, it's so everywhere in our lives these days. It might be interesting for people to kind of get a feel for how these things work.
All right.
And one thing I got to put in a plug for the U.S. military here, because this thing was built by and designed and put up there by the military, and it's one of these things where it has become such a civilian tool. I mean, nowadays it's omnipresent. It's in your car. It's built into your car, and all over the world people use it. And it's fantastically complicated and interesting system. So there are these 24 satellites. Actually, there's about 29 of them. They have spares in orbit just in case they break. And these are what's used to sort of pinpoint where we are. And I'll describe exactly how that works in a second. But what I wanted to sort of talk about was how, you know, orbits and things in general, okay? And so what I wanted to talk about was circular motion, first of all, because if you have, so suppose you have a satellite, which is this little bobbin. Here's the Earth right here, okay? And the thing is going around, and we know there's satellites up there because when we watch satellite TV, you see a little thing on your front yard, right? And it kind of points up at the sky. And the interesting thing is those things are always pointing at the same place. You don't have to go out there and adjust them ever. So those satellites are always at the same spot above the Earth. Okay, so there's a distance from the Earth at which the length of time it takes for the thing to orbit the Earth is exactly the same as the length of time it takes the Earth to make one rotation, which is a day, right?
How'd they figure that out?
Well, that's an easy mathematical thing. My students in physics, you know, 211 can do that pretty easily.
Oh, good. Well, I never took physics, so I don't know that.
Right. But here's what you've got to understand about this. It's kind of interesting. If you spin that around over your head, okay, spin it slow and then spin it faster.
Like?
Yeah, spin it kind of slowly. No, just whip it a little. Now spin it faster. Now, tell me, when you're spinning it faster, is the tension in the string higher or lower than when you're spinning it slower?
It's higher.
It's higher, right? Because to go faster, you stretch the string more. It's harder, okay? And so that's called a centripetal force, the force that keeps something moving in a circle. And for something that takes less time to go around, the force has to be bigger. Now, the only force that is able to make this satellites go around is gravity. And gravity has this neat, interesting property that as you get farther away from the object that's pulling on you, gravity gets smaller. Okay, so that means that if you want something to be going around with a short period, you want the force to be big, you have to be in close. If you're farther out, it takes you longer to go around once. That's why, like, for example, as we go around the sun, planets that are closer than us to the sun, like, for example, Venus, go around faster. A year in Venus is half a year. On Mars, which is farther away, it's maybe 2 years. And so these geosync orbits are about 3 Earth radii, or 3 diameters of the Earth away, like out here someplace. Okay? Oh, what's that? You're pointing? Yeah, right about there. Okay, and they go around once a day, like I said. The GPS satellites, you want them to go around twice a day. That's the way that they've designed. So they're a little closer in. They're not halfway, but they're about there. Okay? And so they go. You know, it takes them 12 hours to go around once, but they don't go around in the same sense like the geosync satellites for communication go around the equator. These other ones, the GPS ones, kind of go around the other way. Okay? So I've drawn a little picture here.
All right, we've got about 30 seconds.
Okay, well, we'll come back and explain exactly how this actually works in a second. So here's the Earth. You can tell I'm an artist.
You are.
That's why I'm in physics, okay? So these things, they're sort of 6 orbital planes, and it's really hard to draw this, so it's kind of a lame picture, I understand. These little things are 4 satellites. Then there's 5 other of these planes that kind of go around the Earth. And so what it looks like, if you go on Google and you Google GPS, for example, you'll see a picture. It's called a constellation. It looks like a bird cage. Okay, and these satellites are always all over everywhere, and it's designed so that at any given time, there's at least 4 that you can see from any point on the Earth.
Awesome.
And when we come back, I'll explain exactly how they tell you where you are.
There you go. That comes your way in 30 minutes. You want to see this yeah, I should not be on TV because I can't even talk today. We're going to weather.
Good call, Rob. Good call.
Yeah.
It is time for a check of your forecast, and everything is just looking